computing. Sorry. All right, welcome everyone. April Infracost community call. There are 5 topics we want to get through, and I'm recording this to put it on YouTube so the rest of the community can see afterwards as well. I think most of us know each other, but it might be good to do a quick intro so the rest of the community knows us as well. I can kick it off. I'm Ali, one of the co-founders, mainly spending time talking to users these days. Who wants to go next?
Tim, I'm an Infracost engineer.
Yep, I'm Hugo. I'm Infracost engineer as well.
Yep, I'm Vadim. I'm also an Infracost engineer.
And I'm Alistair. I'm a co-founder of Infracost and also sometimes an Infracost engineer.
I'm Pat. I'm a software engineer. I worked at Amazon and Microsoft, and now I work at Steady.
Welcome. So what I wanted to start with was an overview of Open Policy Agent and how it works with Infracost. So this is the second iteration we were doing on this. The first iteration was, let me maybe share my screen very quickly in case people aren't aware that Infracost has a Json output. Let me know when you can see my screen.
Yeah, we can see it.
Awesome. Okay, so Infracost breakdown or output or diff, they have a JSON output, and this is the thing that can be used to integrate Infracost with any other tool. So format JSON path. I'm just going to use one of the examples that we have, and I'm going to pipe that to JQ. This is where we learned that Terraform is a bit slow, and Hugo is going to talk about parsing HCL a little bit. This one was pretty fast because Terraform init had run before, but the plan can sometimes take a while. So this is the Infracost JSON output. You can see it's versioned, so we don't want to break people who use this. I've got the share link enabled, so that's why you see that. And as you can see in the examples here, all the resources that are used to essentially render the outputs are available here, including their costs and metadata. And then at the bottom, there's summary stuff around the total cost diff, the total monthly cost diff, and so on. So originally, the idea was that you would install Infracost in your CI/CD, you would install OPA or Sentinel or any other policy checking tool you had. You would take the output of Infracost, this JSON, and use that with the other tool. That worked okay, but what users wanted were that output in the Infracost comment. And this is what we enabled with this new integration. So the Infracost comment command now accepts policy path. So if you write a policy using Rego, which is OPA's language, that checks the JSON and decides if something should be passed or failed, you can now use that directly by just passing that directly to the Infracost comment command, and that results in this red or green output. So you can see this one failed, this one passed. The 3 use cases we're seeing with this one are mainly preventing human error. So I didn't know this thing was going to be that expensive. Well, this is the framework that enables the DevOps team or the FinOps teams to define those things in the same way that unit test frameworks exist and organizations kind of customize it for their own use cases. The other one is just Guardrails. The idea with the guardrail is that perhaps you can fetch the cloud budget from AWS and use that as the guardrail. Rego supports being able to pull in data from other sources, I think. And then finally, this is the one we're exploring next, which is provide advice. So instead of just red or green, can we make it so there's a yellow warning option as well, which says, hey, it looks like you're using this EC2 instance. Instead of GP2, maybe use GP3 because it's better. And that's kind of what we want to explore next with this. Any comments or questions, or does this make sense?
Is there like a for now it's like everyone writes their own policies, but are there plans for like kind of like common policy packs and stuff like that?
Yeah, exactly. This is what we want to explore. I think they will emerge from the community, and it's how we do them and whether you can kind of enable them on a dashboard or where you have to write them and like, you know, put them everywhere in every repo and those kind of things. But I think so. We want to spend time and figure out, I don't know, the most common 50 or 100 policies, and you can then just tick the ones that you want maybe.
Yeah, I think how Styra does it, or the guys who essentially the company behind OPA, they have like a visual builder now, which is part of their enterprise solution, which allows you to build easier OPA things. But I think that's a great idea, like having, like, as you say, just bolt-on packs that you can say, here's like a generic way of, you know, protecting against EC2 instance cost going out of thing. And I think that's definitely the way to go for engineers first. And then there's like a separate persona of that guy who wants to like toy around with it, like in like a kind of dashboard like scenario.
Yep. So one of the things you probably saw when I ran this was that Infracost sometimes feels slow because Terraform init has to run, Terraform plan has to run, and if you're using remote execution, things have to be fetched from Terraform Cloud. So back in, I guess it was February, late January, February, we started toying with the idea that how do we make it easier for people to set up Infracost, whether it's, you know, do you need cloud cred so Terraform init can run, whether it's like this dependency on Terraform and Terraform binaries, or can we just make it super fast? So I'm going to hand over to Hugo to us. Do you want me to stop sharing my screen, Hugo?
Yeah, maybe that'll be good.
There you go.
Good idea. So yeah, as Ali said, I think one of the major challenges that users have using Infracost is speed, and also just interacting with cloud credentials that they don't have. And realistically, when you want to, you know, play around with like a Terraform on your machine and you're changing resources, you want to see a real-time feedback loop of like costs, and that right now we're seeing there's a barrier to that. There's quite a lot of headache for people running it locally and or running and trying to get the creds that they need to be able to access the infrastructure. So right now we're in the midst of like, you know, proceeding along with this. I'm hesitant to call it an experiment anymore because we're getting to a stage where it's proven. And as Ali said, back in February or whatever, we started playing around with this, and we've gone through a strategy of how can we make this a reality. Because at first it was, this is a cool idea that if we can read the configuration files directly and not need Terraform, but is that going to give us the same amount of accuracy as like our plan JSON and relying on the Terraform binary? And we kind of weren't sure. So what we decided to do is, okay, let's build like build all the code and the integration around this to be able to read HCL and provide the functionality there, but benchmark it against our current approach. And so how that happens is that everyone who runs, Infracost breakdown currently, we benchmark their Infracost run against the HCL approach in the background, because you run it in parallel, because HCL is always much quicker than a Terraform CLI plan. So we can benchmark how far off like HCL is in terms of breakdown. And we're trying to get to a place of parity where we can say HCL is this much as good or equal as good as our current approach. And what we've been doing recently in this last month or a couple of weeks or so is we've been focusing on trying to improve areas that we can see inaccuracies. So we understand from like, users reporting issues and also seeing the metrics that we can understand that we have certain problems with certain resources in HCL, and we have certain problems with certain like directory structures in HCL. And in order to do a bit more explaining about why we have those inaccuracies, I'll just show a quick overview of, oh, whoops, sorry. Can you see my screen? So in order why we have these inaccuracies and kind of how these can arise is, forgive my terrible handwriting, apologies. I'm trying to use a tablet and pen, and it's quite hard to do with the screen setup. So on the left hand side, we have Infracost, we've got Terraform, we've got a Terraform provider. In this case, it's AWS Terraform provider, and then we have AWS actual cloud API. And so if we take this example here of a resource of an AWS instance web app, you can see here that this is the raw HCL configuration here. This is HashiCorp's configuration language. So this is what we're going to build, and we ultimately want to tell AWS API, this is the infrastructure we want to build. So what Infracost does with the current Terraform approach is we go, okay, let's go to Terraform, let's plan, let's make Terraform call a plan. And so Terraform goes, okay, I've got this AWS instance configuration. Let's talk to the AWS provider to make sure that all of this schema is correct and that we are in a set environment. And the AWS provider will then also talk to AWS API directly to make sure we have everything correct. And also there are certain attributes that get filled with this plan. And why that's important to know is because this directly impacts the accuracy of HCL versus the current approach. So right now you can see that we have attributes AMI, we've got instance type, etc. But a lot of attributes will get augmented to just the generic HCL after applies, after certain Terraform states are issued, and that happens at the provider stage. And so a common attribute that you'll see added to lots of resources is IDs or ARNs. So right now you can see that there is no reference to an ID or an ARN here, but obviously commonly in Terraform, you can say, you can reference a resource by going AWS instance web app.id. And now that gets added literally after, we communicate with the API, the provider communicates back to Terraform, and it will add the attribute here. So this is problematic for us in terms of HCL approach, because obviously we don't have any of this communication. And if we're going to read the HCL directly, we don't have those attributes. So we have to kind of do like this approach where we say, okay, what attributes do we know are going to be generated? What are the defaults? And we have to almost build on top of the provider layer all of that logic in Infracost itself. And so this is where we have, a lot of hiccups or bugs and issues at the moment, is like certain things that are normally augmented by the provider or like talking to the cloud provider aren't appearing in HCL. And that's normally stuff like defaults around like, billing size or EBS block size or anything like that. And so some of the real fun bugs that we've seen recently is we've been fixing recently, which thanks a huge amount to people in the community reporting to us, is we saw like massive discrepancies between Azure Kubernetes cluster node, and we kind of dug into that and saw why is that, like why is there a massive discrepancy there? And it's actually because if you don't specify like a managed disk size or an OS disk size, is going to add 128 gigabytes of managed disk just to your resource straight away. So that's about $20 worth per node. So, before like a Terraform apply or before anything like that, you have no knowledge that it's going to add a $20 disk size to it. So fortunately, HCL actually allowed us to see that, you know, we have a discrepancy there, but also augment our own approach, you know, because we don't know that even before an apply as well. So we can highlight to the user, and this is what Ali's coming back to earlier around, like, you know, suggestions, etc. Users don't know that they're going to get 128 gigabyte managed OS disk added. Only after apply do they find that out. So we can now, obviously, we'll flag that up as a default, and the same default. Other stuff around blank billing modes for DynamoDB, completely making a DynamoDB table free in HCLs, which is obviously quite fun. But I think the real big bug fixes that we've been doing for this iteration or this sprint is that we had a lot of really good user feedback from users around specific use of really complex third-party modules, and around their use of like conditional statements and counts and referencing resources that were built through really complex third-party modules being built. And so we've done a lot of fixing there in actually our HCL parsing code to fix up that. And that is early numbers that we can see on like how it benchmarks across releases, is that that's been a really positive change, and that it's really impacted the numbers. So I think, you know, the main takeaway from this is that huge, massive thanks to the community, because we couldn't have done any of those had we not had any support from the guys raising issues, showing tickets, and being like, this is a problem, this discrepancy we're seeing. So yeah, massive 2 thumbs up to the community, and we appreciate it.
So Hugo, that stuff is all now in 0.9.22.
Yeah, so 0.922 is like a big release for HCL parsing. We're hoping that it's going to be a really big step forward in terms of reaching the parity that we have with planned JSON. And so far it's looking good. So fingers crossed. But again, I would just like to highlight, if you can and you haven't already as a community member run Infracost HCL, please do. And if you see discrepancies between your normal run and an HCL run, please raise an issue and highlight the breakdown of which resources are different, because it will help us fix the bugs.
Questions?
I'm interested, like, have you all also looked into like specifically like what's happening in Terraform plan that's like making it so slow, and like looked into like the possibility of speeding up Terraform plan in addition to like ditching it? And I'm curious like what you guys found, and if like you've decided to ditch it because there's parts of it you don't need that plan needs. And I'm curious like the thought process behind.
So just to clarify, we're not ditching it, because what we're seeing is there are the deployment systems that the plan already exists. Like you're running in Jenkins or Atlantis, and there's already a plan. So for those use cases, there is no slowness. Like running Infracost is super fast because the plan already needs to be. What we're seeing is on your machine or in GitHub, when you don't have a plan yet, that's when things are slow. So what we're thinking of it is potentially providing an option. Like, do you already have a plan in your CI/CD pipeline and whatever system you're using? Like you're using M0 perhaps, when you want to use our integration, just use the plan JSON method. If you don't, use this other method. But anyway, about the slowness in plan.
Yeah, there's a good question, Pat, and we did look at it quite a lot. And I don't know if you've looked at the Terraform internals yourself, but it is quite involved in there. And I think the reason we chose not to directly contribute or make like a slim version of Terraform is because there's so much stuff in there that we just don't need. And the main thing that keeps Terraform plans slow is communicating with third-party APIs. That's the main thing that makes it really, really slow. And also there's some elements to it that makes it very slow because of the way they construct like this, you know, essentially graph of like resources, and they do like all of this contextual analysis with all of these providers. So it's not the most efficient way to do it, but besides that, even if we made it more efficient for our use case, we just generally don't need a lot of the information that they communicate with the cloud provider API. So and that's to do with like state and like drift of like resources, and making sure that everything is correct in order for you to like actually physically apply those changes to your infrastructure. We don't need any of that. All we need is okay, basically, what are you going to like apply? And the raw configuration in probably 95% of cases is fine for us to do that. Where the problem lies is stuff like potentially infrastructure drift, like where somebody's going on the console and added some like, you know, disk storage, and it's just not reflected in the configuration. And also stuff which like auto scaling groups and things like that, which you really need like a snapshot of your infrastructure at that point in time. But for us as a tool, because we're sitting like almost in that chain before like you apply, and it's more defensive rather than like proactive, I think we're okay with that, and we're like, that's all right, because we just want to be proactive in showing what's going to happen to your cost. You kind of already know, you know, this is where my auto scaling group's at. My DB instance is like, you know, it's got 500 gigabytes of storage, and you can get that information from the pricing. Does that answer your question, or was that a bad explanation?
No, that makes a lot of sense. I'm curious too. You guys said you were benchmarking. Like, do you know like what a typical speed for the two types of?
Yeah, we do. Let me try and get that information, but it's basically like 8,000 times more quicker on average, I think, something like that.
The difference I'm seeing is like with the parsing HCL, it's fast that you can do it in Visual Studio. Like kind of like as you code, we could make it like, you know, show you an estimate. Whereas with the plan JSON, it's just never going to happen. Like for our own infra repo, it takes about 45 seconds for me to generate a cost estimate because of init and plan. So if I'm typing away and like, hey, if I change this DB instance to single AZ, what will be the cost impact? I don't want to wait 45 seconds for that feedback loop.
Yeah.
But with the HCL, it is like less than a second.
Yeah, so it is literally less than a second. Let me just, yeah, runtime milliseconds.
I'm cautious of the time as well.
Oh yeah, sorry, I've gone on.
Alistair, you want to add something?
Yeah, I was just going to say another reason why it's difficult for us to sort of contribute to the plan JSON generation is that there's a license issue as well, because Terraform uses the MPL license and we're Apache 2. So including any sort of MPL code in Infracost, we would actually need to switch our license to be MPL as well.
Pat, what have you seen with the security tools? Like I know a while ago you sent us some really good links of different approaches that the security scanning tools are taking with infrastructure code. Are you seeing a similar kind of, have you seen any of them that use a plan JSON, or did they all go for like the parsing the code?
So lately I've actually looked into TF-lint quite a bit and started working on that. It's interesting you just mentioned TF-lint actually switched their license at some point to use to perform internals. That I know at least is not using the plan, but I have seen like for the security tools, I've seen some that do one or the other or offer both options like you guys, so people can like choose between the trade-offs themselves. But then obviously probably more work on the author side to support both, even though there's, you know, benefits to both.
Yeah, so I think this segues nicely to the next topic, which is automatically adding the cost of a repo to the README. So this issue, I'm just going to share my screen quickly so people can see. This issue was created pretty much when Infracost was starting, very, very early. And The reason we've not been able to progress it much is because, well, there is no plan JSON. When I'm looking at a repo, or if the repo is just a Terraform module, you can't even generate a plan unless we kind of import that and somehow add some temporary or dummy credentials and essentially try and generate a plan. The reason this issue is now getting a lot of comments is that with the parsing HCL option, we can actually do this now. And so I cooked up this in a quick workaround where you can have a badge, a combination of using share links and parsing HCL. So you can create a badge that basically links to a run. And that run is from the repo. What's starting to look like is there's two use cases. One is to show the cost of a module in the README. So if I'm an infrastructure engineer and I'm working on a project and I want to use a couple of modules, before I use those modules, I want to have some idea how much do these modules cost. That's kind of the first use case. And the second use case is I actually have an infrastructure repo and I want to know the cost estimate, the latest cost estimate for that repo. So I tried to dog food this in our internal infrastructure repo. And Vadim, do you want to highlight why I closed my pull request?
Yeah, sure. So the main problem is like this approach with the run link is static. So technically we will have to basically update README every time something changes, which is no go, right? You'll have a huge amount of like update commits. But what we could do is actually get something to the latest, like point to the latest run, and that will grab the latest one. So we don't need to technically change README or anything. You can always go to the actual latest run. And I was thinking about like using the shields, right? I think like there's an action that will basically asks you, hey, create a gist, and we will store information in this gist. So, and the shield will be dynamic. So we also can provide like a link behind it. So technically, like our dashboard can store this information instead of a gist, and it will also point to the latest information from the run on master or whatever. And technically, we get like dynamic like cost or actually anything you want, because like if you saw the what Ali showed, like the whole JSON, you can grab any information and put it there, right? So like, and yeah, and this thing is very customizable, so it can look and work with whatever you need for for your repo.
So until we have this kind of concept, this is the concept that Vadim was kind of proposing or discussing. Until we have this one, Vadim found this really cool action and he's created this example where you can essentially create a badge and the badge is dynamic and it doesn't continually push README changes, so you don't mess up the commit history. And it's using, sorry, it was the other one, right? It was the badges. And it's using this other GitHub action and the JSON format. So this is another use case where combining the JSON format with parsing HCL, you can grab the total cost from that and use that to create a badge, essentially. So the integrations between Infracost and other tools are really starting to look exciting because of parsing HCL and JSON format. So another thing Brett was proposing is pre-commit hooks. Infracost is already integrated with pre-commit Terraform by Anton and the rest of the community. And this parsing HCL could enable us to make something, can kind of make us, at the moment that runs plan, it's a bit slow. You probably don't do that on every commit, but now you could. And you could even look at things like how do we make this more like Terraform docs? So it's kind of embedded almost in the README as well. Any questions on that?
No questions on that.
Just to come back to your question, Pat, about the actual speed, for some reason, I'm having a real challenge, like graphing it over all of these, but I've got an example on here where the TF run took 9,500 milliseconds and the HCL run took 360 milliseconds. So it's about 25 times faster. And that looks about right from across the board, but I can't find an average aggregated example at the moment, so apologies.
Cool. Yeah, that makes sense.
We're pretty much at time. I think I'll just add this to the next. Yeah, I'll add that to the next one because there's no rush. And essentially, I was just going to provide an overview of how the Jenkins and Circle CI integrations work. The TLDR is using the Docker image or the special download URL we've created, which just fetches the latest patch version. So you get automatically the latest resources without having to break your CI/CD pipeline. This is something we enabled for GitHub and the other repos as well using a version tag, but we've now kind of enabled this for any other CI/CD system. If people want to use that, they can still lock to a patch version, or they can just use this. And the rest of it is just using the regular commands like Infracost breakdown and Infracost comment to post a comment. So, but I'll go over the specifics of Circle CI. Anything else anyone want to talk about? Awesome. Thanks for dialing in. I'll put this on YouTube, share it with the community, and we'll keep doing this after next month's release.
Thank
Cheers,
you.
everyone.
Cheers.
Bye.
Cheers.